Welcome to Build Day Live. I'm Alistair Cook, and in this video, we're going to start on a process of migrating from an on-premises environment to the Google Cloud Platform. So this is a project I've been working with Keith Townsend at the CTO Advisor on, and it's the CTO Advisor Hybrid Data Center that is our starting point. I'm going to take some applications from the CTO Advisor Hybrid Data Center and migrate them into Google Cloud and eventually get them improved as well as moved. But this video is going to focus on the mFit tool, which is used for the reconnaissance and looking at your on-premises environment and giving you some suggestions about what changes you need to make and what platforms on the Google Compute platform are actually good for your application. We're going to start with the CTO Advisor Data Center in Chicago and build out with the reconnaissance tool and go through that process. So here we go. Of the assessment, the Google mFit tool requires a Linux box. So I've just deployed this Ubuntu Linux machine here and called it mFit, and we're going to use this to run the assessment. Before we can run the assessment, we need to install the assessment tool. So let's take a look at the installation component in here and see what they tell us to do for installation. So there is, of course, a whole bunch of documentation here, and again, linked in the description. List of prerequisites in here for your machines. You need to be able to talk to the things that you discover. Yeah, we'll hit all of those. But we need this Linux machine. We need to create and change into an M4A folder. So I'm going to grab that code sample, pop into my Linux machine, which you can see here is a nice empty, freshly deployed Ubuntu machine, plenty of free space. So if we just change into that directory we've created, pop back into the instructions, and it says then run this curl and retrieve the mFit executable. So we'll do that. In it, it's retrieving the version number of the latest mFit release, and then at the bottom it says we're going to change the mFit executable to be executable. So we're going to again copy that code sample, pop into the terminal, retrieve mFit, and there is the mFit application itself. So now we actually have our mFit app, and we can run mFit - help and get some help for mFit. So we are going to do the discovery of vSphere first, and then we'll do some assessments and generate some reports. And that's the process here. This tool goes out and looks at your inventory. In our case, we're going to retrieve some information out of vSphere, out of vCenter, and then we're going to go into each of the virtual machines and retrieve in-guest information. So the vSphere discovery piece will just get us the virtual hardware configuration. To get the software configuration, the applications that are installed inside of each of our virtual machines, we're going to need to do the guest type discovery. And I found that a little less than clear in the instructions. Further down it says what we should do is do some discovery, and for the VMware component to actually get the virtual hardware configuration, we can do a discovery directly against VMware, but we can also do a discovery against an output from RV tools. Now, RV tools you may use regularly. It's something that I recommend for my VMware customers, is just run RV tools, do a dump of its configuration on a reasonably frequent basis so you have a reference data. But the collection from VMware is fairly simple. If we just scroll on down through the page here, it says, here's what you do. You specify the username you want to use for discovery, and I'm going to use acook at ctoadc.com, and the vSphere URL. Now I've got that in one of my scripts here. I'll come back and look at these scripts properly later on, but this is what we want to grab out of there, is just the path to our vCenter server. So we'll put back in here. Oh no, we were putting it into here, weren't we? So we're putting our vSphere URL in here. get the right key sequence, and we wanted to not have the HTTPS parts, we just needed the vCenter server name. So we're then going to grab that, copy that code sample, and paste it here into our command prompt, and have it go and do the discovery. Pops up, asks for our vSphere password. That's the password for the user ID that we specified here. And that's my password. And then it says unknown certificate authority, because we have to do this with a, if I remember rightly, a -I switch to say ignore the certificate, because I don't have trusted certificates set up in here. Right, so now that I've allowed the insecure certificate, it's done that retrieval and has found information about my vCenter environment. Right now it knows about every VM that I have, and it knows the hardware configuration, but that's not particularly useful for doing this migration onto Google services. So we need to now go through and do the discovery of the applications that are installed and their configuration on each of those virtual machines. We do this down here in this collecting data remotely using VMware tools. Now everything we're collecting for this project is VMware virtual machines, and so retrieving through vCenter allows us to do this without having to open up firewall holes and allow security between the vFit assessment machine and the machines we're assessing. Now it's not an issue for us here in the CTO Advisor data center, but in real world data centers that may be really beneficial. Get my vCenter user ID. We're also going to need to authenticate inside the guests, and that's a normal part of using the VMware tools to execute commands inside guests. You have to provide some credentials for it. This particular Linux machine has a user ID of VBB, and then I've got to specify which machine we're going to actually retrieve from. In this case, a machine called Granite Web 1. So I grab ourselves that command, but they've dropped off the leading // and I haven't got a -I in there. So let's clean that command up a little bit. So we want to pop it onto a single line just for readability, add that path into local directory, and add the -I switch for insecure access using untrusted certificates. Back in here, paste in our command and do our discovery. vSphere password, and then the VM password. So it uploads a collection script into the machine, then runs that script, and then copies the result back out. A warning here, it couldn't copy to the collected data to var.m4a. This is a permissions issue that is clearly not being set up correctly. It's probably that the user ID that I use doesn't have sufficient privileges in there. I'm going to just pop into that machine, grant some rights on there, but just bear with me and we'll be back in a moment. Okay, I've created that directory, the var m4a directory on the machine, and given everybody rights to write to it. So this time we should correctly have that collection. So now we've actually collected the data, it's come back successfully. The standard out, standard error messages always show up on there. But that is a successful collection of data from one of our virtual machines. I have an Ansible playbook that does the configuration of my machines. I've simply added a play into my playbook that creates that directory and sets the permission so it's world writable. I chose to do that rather than use a higher privileged user ID for this collection. Now that we've got one machine collected, we need to collect from a group of machines, preferably all of our machines. Back up when we did the discovery of the vSphere layer, the entire vSphere layer, it found more than one machine. If I remember rightly, it found 56 VMs. I don't really want to manually enter every one of those 56 VMs. So what I chose to do was to create my own set of scripts. So I have firstly a shell script here, which is going to do a retrieval for all of the machines that I got out of my list of virtual machines. So I have a full list of virtual machines there, and then I also have another collection of virtual machines here. And actually, let's also get newly added one. And what I'm doing in the shell script is just iterating through the names of all of these machines. And then I'm running an expect script. So expect is a standard Linux tool that allows you to say, run this executable, and if it throws this prompt at you, give it this information. And in my shell script, I'm also running that expect script by passing it the name of the virtual machine and also the password to log into it. And you can see they're coming from environment variables. So I've simply set and exported environment variables called Windows password and Linux password. Previously, I had them hard-coded in this script, but that doesn't play very nicely when I'm showing it to you. And you could all see my credentials. That would be a poor security practice for me. So I have that collection of files there. They're all currently on the desktop. So let's find my mFit machines file share. So there's the 3 files. We'll copy them. Find my mFit machine, which is just here, and put all 4 of those files in my M4A folder. Sorry, 3 files. And then if I come into here, we'll see those files. And then I can simply run the ctoadc shell script. I'll stop the recording now. It's 2:50 p.m. as we start. A lot of Windows machines to retrieve from. That's going to take quite a while. So we'll just fade to black and then come back when it's finished. Well, now it's completed the collection. I had a couple of issues along the way. You can see that one of the machines, it couldn't retrieve the files, and the whole process took around 15 minutes to do the collection. So we'll have incomplete information because of that machine where the files couldn't be copied. Now that we've done the collection, we have data about a bunch of machines. Our next step is going to be to process that data, and that's down here in the collection data. So we've got this assess function that runs. So we've got database populated with our all of our data, all of the machines that we're going to look at, and now we're going to do an assessment. So I'll just copy that, pop the assessment in here, run the assessment, and it goes through and looks at, in my case, 56 machines. So running the assessment is much quicker than the gathering of data. I really do want to ask the mFit team whether you can parallelize that gathering of data. And then we're going to generate a report. So we want a report, let's call this one basic.html. So we'll run the basic HTML one. And let's actually put that in our home directory rather than our current directory. Better not have that space. There we go. And let's take a look at that. So it's an HTML file format report that has been put down here. It's mapped to my G drive, and we can just open that basic report. And it says we've looked at 56 machines. We can see that there are roughly a 50-50 split between Linux and Windows, and we've got some modernization benefits in here. We've got some just overall analysis. We've got some details about the kind of places we could migrate to. So we can see some Linux systems that could be moved across to Anthos and Google Kubernetes environment. Looks like they could all go across onto Autopilot, and most of them could land on Cloud Run. We've got a bunch of other information in here, so good little bit of starting information, but this is just the short report. This is the one that you hand up the chain a long way to say this is where we're at and what we need to move. What you usually want to do is run the full report. So we're going to do that, So that's going to be called full.html. And you just put a --full in here. And that should produce us a full HTML file with quite a lot more information in it. In this report, we've got a lot more detail. We've got, in particular, details of every single virtual machine. And we can see what the suggestions are for migration of the various elements in here. Now, I wanted to take a look at the machine called Obsidian, which is the one that we're actually migrating in this particular project. And so you can see at the top it says we've detected there's some applications. Well, Apache is in here. Yep, there's a web service running. It says we've got some disk mounts, says we've got some tools installed. It says it's an excellent fit for moving to Google Compute Engine, Cloud VMware Engine, or bare metal on VM on Anthos. So straight shift the virtual machine is absolutely possible. But you can see that there's also some effort required to get to using either GKE or GKE Autopilot. And as we drill into that, we can see what it means. So minimal effort means, well, we've found a database. Yes, this particular machine has MySQL running in it. And so we've got this recommendation, migrate to Cloud SQL as the change that you'd need to make. But everything else seems to fit pretty well. Then when they say it requires more effort, major effort here, to containerize with GKE on Autopilot, it says we've got a memory that exceeds the maximum pod size. So the memory configured on this EC2 instance is 32 gigs of RAM, which is more than you can have in a pod with GKE or Autopilot. That's the containers as a service. We'd need to consider whether having less RAM is going to be suitable for our application to make it fit. But that's about all. That's all the things that were going to be a restriction for us on GKE. If we then start looking at things like moving to Cloud Run. So Tomcat containers, I'm not using Tomcat. The server-side component of this application actually runs in PHP. So maybe containerize with Cloud Run is listed here as not a fit. And so here we've got, yep, there's a database found. It's not going to work for Cloud Run because the database. Now we know that we can migrate to Cloud SQL, and that's what we will show. And then you can see that the CPU and memory configuration, this machine has more resources than Cloud Run could deliver. But other than that, it's a good fit. We can see that there are multiple options about how we can migrate these things onto Google services. And we can see that for each and every one of the machines that are in here. So if we go back and take a look at Granite. Now Granite is the same as Obsidian, just a more recent, it's a more recent version of Ubuntu that's in here. So Granite, this machine that is just called Granite, is a version of the same thing. And you can see that we've got no fit and insufficient data. We haven't necessarily got all the information we want out of Granite here. So it looks like we don't actually have the application information. So maybe I didn't actually do a retrieval of the information from Granite. That's probably a sign that I should. It's in this list because it's one of the virtual machines we discovered, but because we didn't do a retrieval from within it, that's why it doesn't tell us what version of Linux it has. We haven't actually got details of the applications. On the other hand, if I look at Granite Q2 here, so this is a distributed version of my application, we can see even down to Cloud Run it's an excellent fit because this particular machine doesn't have a database in it, it just runs some Python code. And just says we might need to bring some data along. We don't know for sure because there is a file system here, and then a little bit of effort required to make sure that we have a static host file configuration. I'm really impressed with the amount of information that mFit retrieves out and how well it maps to the changes you need to make as you migrate from on-premises into Google Cloud Platform and the changes that your applications are going to require. In the coming video, I'm going to take that Obsidian machine that requires some changes, and I'm going to walk that through the process of getting it onto the Google Cloud platform, particularly initially as a virtual machine, and then later improving it and getting it onto the Google Kubernetes environment. Stay tuned for those videos and lots more great content coming out from the Build Day Live team, and keep a watch of the Build Day Live site for more blog posts about this too.